Have you ever looked up at the night sky, at that vast velvet canvas dusted with countless stars, and wondered? It is perhaps the most profound question we can ask ourselves. Are we alone in this immense universe? For all of human history, this question has been the domain of philosophers, poets, and dreamers. But today, in this remarkable moment of our civilization, that question is moving from the realm of speculation into the world of science. We are building machines, incredible extensions of our own senses, to go out there and search for an answer. The search for life beyond Earth is one of the greatest adventures humanity has ever embarked upon. It forces us to confront our own place in the cosmos. This journey is not just about finding alien organisms. It is about finding a reflection of ourselves in the vastness of space. Europa is one of Jupiter's largest moons, a world slightly smaller than our own moon. From a distance, it appears as a pale, serene orb, crisscrossed with a fascinating network of reddish-brown lines and cracks. These lines tell a story of a dynamic and active world, a world with a hidden energy source that twists and breaks its icy crust. Scientists believe that Europa's icy shell is floating on top of a vast global ocean of liquid salt water. This isn't just a small trapped lake. It is an ocean that could contain more than twice the amount of water found in all of Earth's oceans combined. The reddish-brown material that fills the cracks could be the chemical signature of Europa's hidden sea right there on the surface. The search for life often begins with a simple mantra: follow the water. On Earth, wherever we find liquid water, we find life. We find it in the boiling hot springs of Yellowstone, in the deep-sea hydrothermal vents where no sunlight can reach. The energy doesn't come from the sun, which is too far away. Instead, it comes from Jupiter's enormous gravity that pulls and squeezes Europa. This tidal heating could potentially power hydrothermal vents on the seafloor, creating oases of life like those on Earth. So, Europa presents us with a compelling trifecta. It has a vast ocean of liquid water, a source of energy from tidal heating, and the necessary chemical ingredients. All of this is protected from the harsh radiation of space by a thick, insulating shell of ice. It is a potential cosmic petri dish that has been stewing for billions of years. We have already sent probes to fly by Europa, like the Galileo spacecraft in the 1990s, which gave us our first strong evidence for the subsurface ocean. NASA's Europa Clipper, scheduled to arrive at Jupiter in the coming years, will perform dozens of close flybys with powerful instruments. Looking further into the future, the ultimate goal is to land on the surface. A lander mission would be a monumental engineering challenge. The most ambitious dream is to send a probe through the ice into the ocean itself, a lone probe swimming through an ocean 1 billion kilometers from home. Imagine the scene in Mission Control. Years of planning, billions of kilometers of travel, all leading to this moment. Data is streaming back from the Europa lander. The scientists are gathered around their screens, faces illuminated by incoming data. Then the first results appear. A spike on a graph showing complex organic molecules, the very building blocks of life as we know it. The microscope begins to scan the sample. At first, nothing but tiny grains. But then, something comes into focus. Small, simple shapes that look biological. The room falls silent. This would be the discovery of the century, perhaps of all time. We would have found life, and in that moment, our perspective of the universe would be forever altered. The scientific community would react with excitement and profound caution. The data would be scrutinized by teams of scientists all over the world. Science is built on skepticism, and a discovery of this magnitude would require the highest possible standard of proof. Once confirmed, a new era of astrobiology would begin. Does this life use DNA like us? Or does it have a completely different genetic system? Finding life with completely different chemistry would mean that biology is not a fluke, but a fundamental property of the universe. The discovery would transform biology from the study of a single data point into a comparative science, showing us the deeper principles of what it means to be alive. The news would spread across the globe like wildfire. It would be on every news channel, website, and phone. The discovery would capture the imagination of all humanity, a unifying moment for our species. Religious communities would engage in deep reflection, as the discovery would have profound implications for beliefs about humanity's place in the universe. Philosophers, artists, and musicians would be inspired to create new works that grapple with this new reality. The discovery would spark a new golden age of space exploration. Public support for space agencies would soar. More young people would be inspired to become scientists, engineers, and explorers. The journey to the stars would feel achievable. The discovery would force us to confront one of the most difficult questions in science. What is life? We have a list of characteristics. Life grows, reproduces, metabolizes, evolves. But are these the only possible characteristics? If Europa's microbes share our DNA-based biochemistry, it would suggest a standard model for life. But if they have completely different biochemistry, the implications are even more staggering. This understanding would reshape our search for life on exoplanets, expanding the range of environments where life might thrive. The impact would ripple through every field of science, from geology to chemistry to physics. The discovery would show us that the cosmos is not just dead rocks and sterile gas, but is pregnant with possibility. If life has happened twice in our solar system, what does that mean for the rest of the galaxy? Our Milky Way contains hundreds of billions of stars. The universe would suddenly seem transformed from a vast empty expanse into a cosmic ocean, teeming with potential islands of life. The SETI project would no longer seem like such a long shot. If life is everywhere, perhaps somewhere it has evolved into something that thinks and builds. Each discovery teaches us more about ourselves and our origins. The search for life on Europa is about holding up a mirror to life on Earth. So, as we look up at the night sky, we should do so with hope and wonder. The universe is not finished with its surprises. The discovery of microbes on Europa would be a beginning, not an end. What else is out there? We don't know. And that is the most exciting thing of all.